Thank you so much for joining me today. I will go through many solved examples about beams. What I covered last meeting, just to give you a hint, if we have a beam, this beam is supported by supports, whatever the type of supports, and I'm looking for what are the value of the internal forces at a specific point. First step, I have to calculate reactions. Second step, I have to do cut at this specific point. This cut will divide your beam to two parts, one on the right and one on the left. Which part I'm gonna use, it's up to you. This one or this one. Once you have your part, for example, this one, go ahead and put everything, put reaction, put given load, whatever you have. At your cut, I will have three internal forces. One is called normal or axial force, capital N. One is called shear, capital V. One is called the moment, capital M. Then I can apply three equilibrium equations, summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0 to figure out the three internal forces. Let's do more examples today. First example, I'm given a beam with two supports, one at A, which is hinge, one at B, which is roller. I need to figure out the three internal forces: axial force, capital N, shear force, capital V, bending moment, capital M, at point C. Point C is located 1.5 meter from support B. Regardless what is the required, I will start with reactions. This is the first step. Without reactions, you cannot solve this kind of problem. How to figure out the three internal forces at a specific point in a beam. First step, reactions. Since A is a hinge, I will have two reactions, one horizontal XA, one vertical YA. B is a roller, so I will have one reaction YB. Before starting to apply the three equilibrium equations, summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0, I would like to remind you something we learned before. If we have uniform distributed load, do you remember this kind of loading? The value is W and the length of this distributed load is L. I will convert this distributed load to one equivalent. Do you remember what was the value of this equivalent load? Equal W times L. The location of this distributed, this equivalent load at the centroid of this rectangle. That means it will be at distance L divided 2 from this side and L divided 2 from the other side. Does that make sense? So before applying the three equilibrium equations, I have to convert this distributed load to one equivalent. How much? This equivalent load, it will be 9. This is the value of the distributed load time the total length of this distributed load, 3 meters. So it will be 27 kilonewton. The position of this distributed load will be 1.5 from this side and 1.5 from the other side. That makes sense? This is what we learned in module number 5 about distributed load. Now I can apply the three equilibrium equations. Summation f of x equals 0. I have only positive xa. Nothing else equals 0. So this reaction will be 0. Summation f of y equals 0. I have positive YA, I have positive YB, I have negative 12, I have negative 27. Anything else? I don't think so. So equal 0. I can simplify this equation. YA plus YB will equal 39, I think. Summation moment at any point. I'm going to take moment at A, the point with the highest number of reactions. I'm going to assume my clockwise rotation is my positive direction. So XA will be multiplied by distance. YA multiplied by distance. 12 time distance. 27 time distance. YB time distance. I have to list everything in this beam. So what is the distance between XA and A? 0. YA and A? 0. 12 and A? 1.5, and both of them are perpendicular. 27, the equivalent load, and A, I think we have 1.5, 1.5, 1.5, so it will be 4.5 meter. What is the distance between YB at point B and A? The distance will be 6 meters. I don't care about the sign of this term. I don't care about the sign of this term. 12 times 1.5 will rotate clockwise, will be positive. 27 times 4.5 will be positive. It's clockwise. YB, it's counterclockwise, will be negative. The only unknown in this equation is YB. I can figure out the reaction YB. This reaction will be 12 times 1.5 plus 27 times 4.5 divided by 6. I got 23.25 kilonewton. If you go back here and put YB 23.25, the only unknown in this equation is YA, so the value of YA will be 15.75. So this reaction equal 23.25, and this reaction is 15.75. This is the first step to solve your problem. This is the first step to solve your problem, to figure out the reactions. Anybody has any questions so far? Guys, do you have any questions so far? Looks good. Thank you. The next step, and be careful, I will cut this beam at point C. So I will do cut here. This cut will divide your beam to 2 parts. The first part, one on the right-hand side, and the second part, one on the left-hand side. You have to decide which part I'm gonna use, the right part or the left part. For me, personally, I will use the smallest part. So I will decide to use the right part. What do you have on the right part? So this is step number 2 after I did section. Be careful, please. What you have on the right side, I have this part. I did cut here. At this point, it's called C. And this point is called B. This part has reaction here. How much? 23.25. This part has part of the distributed load. a little part of the distributed load, this part only, and this distance equal 1.5 meter. Do you think, and this value is 9 kilonewton per meter, do you think we have something else on the right part? I have reaction at B. I have a little bit of the distributed load, not all the distributed load, just only this part of the distributed load. At your cut, I should expect axial force, capital N, shear force, capital V, and bending moment, capital M. So I will have the three internal forces. To be more specific, just a second. This moment, like this. So we have capital N, we have capital V, and we have capital M. This part is in equilibrium. So it's a part, not a joint. So I will apply one more time. Summation f of x equals 0 for this part. Summation f of y equals 0 for this part. Summation moment at any point equals 0 for this part. Before starting, make sure you convert this distributed load to equivalent. How much? 9 times 1.5 equal 13.5. And your distance will be 0.75 from this side and 0.75 from the other side. Be careful. What I have right now on this part, only part of the distributed load with a length 1.5. So the equivalent will be 9 times 1.5 and will be located at the mid distance. Go ahead and apply your equilibrium equations. Summation f of x equals 0. I don't have anything in x except the negative capital N will be 0. So capital N will be 0. We don't have axial force. If you apply summation f of y equals 0, I have positive V. I have negative 13.5. I have positive 23.25 equals 0. The only unknown in this equation is capital V, which is the shear force. Your value will be 23.25 minus 13.5. I got negative 9.75. Negative means I assumed the wrong direction. Your shear is going up. I'm sorry, it's wrong. It should be go down. That makes sense? Summation moment at any point equals 0. I'm going to take moment at the cut, C. I'm going to assume my clockwise rotation is my positive. I have to consider everything. Capital N time distance. Capital V time distance. Capital M does not need distance because it's a moment. 13.5 time distance. Your reaction 23.25 time distance equals 0. The distance between capital N and your section, your cut is 0. Capital V and your cut, 0. Your moment does not need distance. 13.5, the equivalent distributed load, and your cut C, the distance is 0.75. 23.25, the reaction, and your cut, 1.5. I don't care about the sign here. I don't care about the sign here. Your moment, based on your assumption, will be positive. 13.5 time distance will rotate clockwise, will be positive. Your reaction time distance will rotate counterclockwise, will be negative. The only unknown in this equation is your capital M. I can find it out. It will be 13.5 times 0.75 minus 23.25 times 1.5. I got positive 24.75. Positive means this direction for the moment is correct. So by the end, I can say I have three values for the three internal forces. Axial force equals 0. Shear force equal 9.75 should go down. And your moment equal 24.75 like I assumed. Anybody has any question so far? Any question so far? We have one more example. Also the same sequence. We are looking for axial force, capital N, shear force, capital V, bending moment, capital M, at point C in this beam. First step, I have to figure out the reactions. A is a hinge, so I will have two reactions, YA, XA. B is a roller, so I will have only one reaction, YB. Do you have any distributed load, anything? No. So I will start to set up my equilibrium equation. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. If you apply summation f of x equals 0, I have negative xa, I have positive 400. This one is 400. This one is negative xa equals 0. From this equation, xa will equal 400 positive. That means I assumed the correct direction for xa, 400. Piece of cake. Summation f of y equals 0. Oh my goodness. Positive ya, positive yb equals 0. I don't have any force given in y direction except the two reactions. That's fine. I cannot say both of them equal 0. Guys, if you have a number plus another number equals 0, I cannot say this one is 0 and this one is 0 because maybe this one is negative 5, this one is positive 5. Maybe this one is positive 4, this one is negative 4. Maybe this one is positive 6, this one is negative 6. I cannot say both of them equal 0. What I can say, ya plus yb equals 0. That makes sense? So mathematically, what I can say only, ya plus yb equals 0. Summation moment at any point equals 0. I'm gonna take moment at A, the point with the highest number of reactions. I'm gonna assume my clockwise rotation is my positive. Go ahead and include everything. xa time distance, ya time distance, 400 time distance, yb time distance equals 0. Be careful. The distance between xa and a, 0. The distance between ya and a, 0. The distance between 400 Newton at this location and a, anybody can tell me what is the distance between 400 and a? Can you write it in the chat? Anybody can tell me this 400 Newton will be multiplied by what? Thank you, Angel. Yes. This force is located at this top. Since this force in a horizontal direction, your distance will be in a vertical direction. So the vertical distance between this position and this position will be 1 meter plus 0.2, the radius of this circle, it will be 1.2. I'm sorry, 1.2 here. Meter. That makes sense? It's not 1 meter, it's 1.2. Why I'm looking for vertical direction of a dimension of the distance? Because your force is a horizontal. YB at this location and the point A, the horizontal distance is 5 meters. I don't care about the direction of this one, because they will be 0. 400 times 1.2 will rotate clockwise, will be positive. YB times 5 will rotate counterclockwise, will be negative. That means your reaction YB will be positive value. How much? $96 Newton. If you go back here and put YB 96, the reaction YA will be negative 96. Anybody remember what is the meaning of negative value for your reaction? I assumed the wrong direction for YA. It should be go down. Yes, thank you, Ivan. And the positive value for YB means the correct direction you assumed. So this one is correct, 96. This one is wrong. It should be down. How much? 96. And this one is not correct. That makes sense? This is the first step, is reactions. Second step, I will do section at point C. So here is your section at point C. This section will divide your beam to 2 parts. I will select the smallest one. So I'm gonna use the left part, which is the smallest one. The right part is okay, it's correct, but we have many things. We have big part. So I'm gonna use the left part. What do you have in your left? Here is the left part. I did cut here at point C. At point A, I have horizontal reaction equal 400. I have vertical reaction downward. This is the correct direction, 96. Nothing else. Also, this distance equal 1.5 meters. At your cut, I will put 3 internal forces: axial force capital N, shear force capital V, bending moment capital M. All of them at point C. Once you set up your part with everything, reactions and the given force and your internal force, I will apply the equilibrium equations one more time, but for this part only. Summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. For this part only. If you apply summation f of x equals 0, I have negative 400, I have positive capital N equals 0. Your capital N will be 400. Positive, I assumed this direction correctly. Summation f of y equals 0, I have negative 96, I have positive V equals 0. Your capital V equal 96. Positive means, positive value here means, I assumed is the correct direction for V. Summation moment at any point equals 0. I do recommend to take moment at the cut, C. I'm gonna assume, for example, counterclockwise is my positive. It's up to you. So 400 time distance, 96 time distance, V time distance, capital N time distance. Your capital moment M does not need distance, equals 0. I think the distance between 400 at this point and the point C will be 0. Hey, 400 is a horizontal force. That means your distance must be vertical. Do you have a vertical distance between this position and this position? No, 0. 96 at A and the point C, we have a distance 1.5. Keep in your mind, 96 is a vertical force. Your distance will be horizontal, that's fine. Capital V and the C, we don't have distance. Capital N and the C, we don't have distance. Capital M does not need distance. So this term will be 0. This term will be 0. This term will be 0. 96 times 1.5 will be counterclockwise. And your moment you assumed it counterclockwise, it will be negative. The only unknown in this equation is your M will be negative how much? 96 times 1.5, I got 144. Negative means I assumed the wrong direction. The correct direction should be clockwise, not counterclockwise, like this. So by the end, I have 3 values. The axial force, the shear force, the bending moment at this specific point C in this beam. 2 steps, your reactions and do your cut. Does that make sense? Any question? One more example. I have a tricky here for reactions, and I need you to pay more attention. We have element AE. A is hinge. And this element, vertical element, has something here called 2 force member. If you look to this 2 force member, you will have here hinge or pin, and here connected to the element another hinge or pin. This element or this member, 2 force member, based on the given information, CB is a 2 force member. If you have this member, in your case, I will figure out the reactions like this. This is your member, vertical member. At A, we have hinge, so I will have 2 reactions, YA and XA. And I am given a force here, 6 kilonewton. Go ahead and remove the 2 force member and put at point B 1 force as your reaction. This force or this reaction will be directed in the same direction of the 2 force member. So how to solve a beam or reactions? How to solve for reactions? If you have this member in your structure, which is called 2 force member. If you have this member, go ahead and remove it and put at this contact point B one reaction. In which direction? In the same direction of the deleted member. Before starting to apply summation f of x equals 0 and the summation f of y equals 0 and the summation moment at any point equals 0 to figure out the reactions, I need to break this reaction to two components. If I'm assuming this is my angle theta, so this component will be r cosine theta, and this component will be r sine theta. So guys, one more time, we have a little technique which is new a little bit in this problem. We used that we are given reactions at the given supports. But in this problem, we are given a new part or new member, which is called two-fourths member, member CB. This member is a special member. If you look to this member, it's a member with two pin. We have pin or hinge at this end and another pin at the connection with the beam or with the structure. This member is called two-fourths member. How to figure out the reaction? If you have this member, go ahead and remove it and put at the contact point with the beam one reaction in the same direction of this member, R. Looks like a roller, but inclined roller. That makes sense? Since this reaction is inclined, we cannot work with this reaction as it is. So I will break it to two components, one horizontal and one vertical, using this angle. Before going, I would like to highlight something. This angle theta is inside a right angle triangle. The horizontal length is 3 meters. The vertical length is 4 meters. 4 meters. 3 plus 1. 4 meters. That means the hypotenuse will be 5. That means sine theta is known 3/5. Cosine theta is known 4/5. That makes sense? So let's move forward. If you apply summation f of x equals 0, I will have positive xa. I will have negative r sine theta. I will have positive 6, all of them in horizontal direction, x direction, equals 0. Unfortunately, I cannot find anything because I have two unknowns, r and xa. Summation f of y equals 0. What do you have in y? I have positive ya. I have negative r cosine theta. Nothing else in y direction. So equals 0. Just to give you a hint, just a hint. Sine theta is known, 3/5. Cosine theta is known, 4/5. But the problem is r is unknown and xa and y is still unknowns. So let's move forward to the third equilibrium equations. I'm going to take a moment at any point. The point with the highest number of reaction is A. I'm going to assume my clockwise rotation is my positive direction. So I have xa time distance. I have ya time distance. I have r cosine theta time distance. I have r sine theta time distance. I have this 6 kilonewton time distance equals 0. I listed everything. Let's go. What is the distance between XA and A? 0. YA and A? 0. Anybody can tell me what is the distance between R cosine theta at this point B and A? Keep in your mind. Keep in your mind. This distance will be 0 because R cosine theta in a vertical direction. That means your distance must be horizontal. Do you have any horizontal distance between the two positions? No. However, R sine theta at the same point, the distance between R sine theta and the point A is 4 meters. Because your 4 meters is measured in a vertical direction. Because your R sine theta is horizontal. And the 6 meters, the distance between 6 kilonewton and the point A, the total vertical distance equals 7. I don't care about this term. I don't care about this term. I don't care about this term. R sine theta times 4 will be counterclockwise, will be negative. 6 times 7 will be clockwise. It will be positive. Keep in your mind, sine theta equals 3/5. The only unknown in this equation right now is R. I can find out the reaction R. So your reaction R will be 6 times 7 divided by 4 times 0.6. I got 17.5 kilonewton. If you go back here and put R equals 17.5, I can find out XA, this reaction. It will be 4.5. So this reaction equals 4.5. If you go back here and put R 17.5, your reaction YA will be 17.5 times 4/5. It will be 14. YA equal 14. So this reaction equal 14. Does that make sense? So by the end, I figured out the reactions at A. Keep in your mind, we are looking to figure out the internal forces at point D. So I will cut the vertical beam at this section D. So we have two parts, this part or this part. I'm gonna use the lower part. If you draw the lower part after your cut, let me do it here. Step number 2, I did my section. Looks like your section will be this part. So I will have this part and I did cut here at point D. And this is point A. Remember, at point A, I have two reactions, 4.5 and 14. 4.5 like this, 14 like this. Nothing else on this part AD. At your cut, I will have capital N parallel to the member, capital V perpendicular to the member, and the capital M looks like this at your cut. Keep in your mind all the time, If your member is horizontal, your capital N will be parallel. If your member is vertical, your capital N will be parallel. I don't care horizontal or vertical. Your capital N parallel, because this is axial force, must parallel to the axis of the member. Parallel to the axis of the member. This is the meaning of axial force. Once you set up your part, and keep in your mind also, I forgot to mention, the vertical distance between the 2 points is 3 meters. Once you set up your part, I will apply 3 equilibrium equations. Summation of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0 only for this part. Let's start. Summation f of x. In x direction, I have positive 4.5. I have positive v equals 0. So your v will be negative 4.5. So the value of shear in an opposite direction to left, not to right, equal 4.5. Summation f of y equals 0. I have positive 14. I have positive capital N. Nothing else. Equals 0. So your capital N will be negative 14. That means this direction is wrong, should be down, which means compression. I'm gonna take moment at A. I'm sorry. I'm gonna take moment at your cut. I prefer to do moment at cut. I'm gonna assume my counterclockwise is my positive direction. So your capital N time distance, capital V time distance. Your capital M does not need distance because it's already a moment. And 4.5 time distance, 14 time distance equals 0. Keep in your mind the distance between capital N and D, 0. Capital V and D, 0. Your moment does not need distance. 4.5, the distance between 4.5 and D is 3 meters. The distance between 14 and D is 0. Hey, 14 is a vertical force. That means your distance must be horizontal. Do you have a horizontal distance between the two positions? No. This term will be cancelled. This one will be cancelled. This one will be cancelled. Based on my assumption, counterclockwise, this one is clockwise, so it will be negative. This direction, 4.5 times 3, will rotate counterclockwise, it will be positive. The only unknown in this equation is your capital M. Your capital M will be 4.5 times 3. It will be 13.5 positive. Positive means I assumed is a correct direction. So by the end, at your point D in this member at this location, I have axial force equal 14. I have shear force equal 4.5. I have moment equal 13.5. That makes sense? So the only tricky in this problem, I have a two force member CB. Before starting to calculate reactions, I removed this member and I put only one reaction in the same direction of the member. So this reaction, unfortunately, is inclined. So I broke it to two components. Besides, I have two reactions at A because it's a hinge. Then I started to figure out my reactions normally. Summation of x equals 0, f of y equals 0, summation moment. These equations helped me to figure out the reactions. Does that make sense? Once you get your reaction, go ahead and do your cut. Decide which part you are going to use. Set up your part and apply your equilibrium equations one more time for this part. That makes sense? Anybody has any questions so far? Guys, do you have any questions so far? Last problem for our meeting today. Another technique It looks like what we did here, but in a different way or different given. We are given a beam AD, and the A is a hinge. And this beam is supported by this cable. If you have this scenario, cable, we need to remove this cable before starting to do reactions. So here is my beam. At A, I have two reactions because it's a hinge. Y, A, XA. We are given a force here. How much? 200 Newton. We are given a moment here. How much? 800 Newton meter. I will delete the cable and I will put a reaction at the contact between the cable and the beam. This reaction R will be in the same direction of this cable. So following the position or following the direction of this cable, I will put one reaction at point E. So this is the case right now. This is the case right now. This one is 200. So if you have two force member, go ahead and remove it and put one reaction in the same direction of this member. If you have a cable supporting your beam and you would like to figure out the reaction, go ahead and remove this cable and put one reaction in the same direction of the cable. Does that make sense? Then I can start to figure out these reactions by applying summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. Summation f of x, I have positive xa, I have negative r, nothing else I can do. Summation f of y equals 0, I have ya positive, I have negative 200 equals 0. So your reaction ya will be 200. That's fine. We are good. This reaction is 200. Summation moment. I'm going to take moment at A. Assume clockwise is my positive direction. So I will multiply xa by distance, ya by distance, r by distance, 200 by distance. 800 does not need distance, equals 0, because this 800 is already a moment, does not need distance. Keep in your mind, you are sitting at A, so the distance between XA and A 0, YA and A 0. Between R and A is a vertical distance, 1 meter. This vertical distance is 1 meter. That makes sense? The distance between 200 and the A is a horizontal distance equal 4 meters. And the 800 does not need distance. I don't care about the direction of this one or the direction of this one. R time 1 will rotate counterclockwise, will be negative. 200 times 4 will rotate clockwise, will be positive. 800 is given clockwise, will be positive. The only unknown in this equation is your R. I can find out the value of R. It will be positive 1600 Newton. If you go back here and put R 1600, the value of XA will be positive 1600 Newton. So this reaction equals 1600. Does that make sense? These are your reactions. We are looking for the internal forces at point C. Here is point C. I will do cut at this point C. This cut will divide your beam to two parts. Part on the left and another part on the right. I do recommend to use the left part, which is very small. So I will do my cut and I'm gonna use the left part. Your left part looks like this little part, AC. Here is your cut. Here is A, and this is point C. Keep in your mind, at A, I have two reaction, 1600 and 200. Nothing else. At your cut, C, I will have three internal forces. Capital N, parallel, capital V, perpendicular, and the capital moment M. Keep in your mind, this horizontal distance equal 1 meter. Go ahead for this part and apply three Chromium equations. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. If you apply the three Chromium equations, summation of x, we have positive 1600. We have positive capital N equals 0. Your capital N will be negative 1600. Summation phi equals 0, we have positive 200. We have positive V equals 0 in y direction. Your capital V will be negative 200. Negative means I assumed there's a wrong direction. I'm gonna take moment at my cut, C. I'm gonna assume my clockwise is my positive. So I have capital N time distance, capital V time distance. Capital M does not need distance because it's a moment. I have 200 time distance. I have 1600 time distance equals 0. The distance between capital N and the C, 0. Capital V and the C, 0. Your moment does not need distance. 200 and the C, the distance is 1 meter. 1600 at A and the C, your distance is 0. Why? Because 1600 is a horizontal force, so I'm looking for vertical distance. Do you have a vertical distance between the two positions? No. I don't care about the sign. I don't care about the sign. I don't care about the sign. This given moment or this assumed moment is counterclockwise. It will be negative. This 200 times 1 clockwise will be positive. The only unknown in this equation is your capital M will be positive 200 Newton meter. By the end, I can say at point C, at this location, I have three internal forces. Axial force equals 1600, shear force equal 200, bending moment equal 200.